All right, so the Pythagorean identities. When working with the unit circle, that these three identities are always true. That we have that sine squared t plus cosine squared t equals 1. In other words, if you take any point on the unit circle, there we go. If we take any point on the unit circle and you square them and add them together, they equal 1. Right? So I want you to try that. Okay? Go ahead and pick one point, any point on the unit circle, ignoring tangent, using sine and cosine. Square the two numbers and add them together and see if you get 1. Okay, everybody do it. Square them and add them together. Sine squared plus cosine squared equals 1. So pick any one you want. Could be 135. Could be 240. Could be 315. Right?
My batteries are low. Oh, yeah.
All right. Do it without your calculator.
$10 to put batteries in.
Do it without your calculator then. Okay, so that also goes for tangent and secant squared, and the relationship between cotangent squared and cosecant squared. Now, all of those things were developed from the very first Pythagorean identity that sine squared plus cosine squared equals 1. That if I divided everything by sine squared, then I would have 1 plus cotangent squared equals cosecant squared. Or if I divided by cosine squared, then I would have tangent squared plus 1 equals cotangent or equals secant squared. And the thing is that these are the three main ones, but all three of them can be written three different ways. Just depends what's alone on one side equal sign. So for instance, with sine squared plus cosine squared equals 1, okay, 1's by itself. But I could rewrite it so that sine's by itself and cosine are by themselves. So you have to be able to understand that they can be written any of these ways. All of them can be written. So there's three main ones, the top three, but they can be written 6 other different ways too. Okay? So all of them can be written in 3 different ways. Just depends on what's on one side by itself. So what we're going to do is we're going to use those facts to be able to prove identities or simplify expressions. So look at this one here on number 3. It says cotangent squared times sine squared plus sine squared. Okay. Now, one of the things that we want to do is that whenever possible, sometimes it's easier to work with sine and cosine rather than something else. So for instance, cotangent squared. I can write that a couple different ways. I could write it as, where to go? I could write cotangent squared. I'm missing. Okay, I guess I didn't write it up here, but it's here. Okay, I could take this one here. I could write it as cotangent squared equals cosecant squared minus 1. Okay. So I could change this to cotangent squared. I could change it to cosecant squared minus 1. Okay. I'm not gonna, because that would actually make this harder in this case. But one thing we learned that you have written down somewhere, that tangent is equal to sine over cosine, and that cotangent is equal to cosine over sine. Okay. Actually, we have that. Oops, right there. Okay. Tangent equals sine over cosine. Cotangent equals cosine over sine. And that also applies for squares, cubes, fourth power, fifth power, whatever, as far as this relationship goes. Okay? I can have sine squared over cosine squared is tangent squared. Sine cubed over cosine cubed is tangent cubed. That does not work for the Pythagorean identities. They all have to be squared. Can't be cubed, can't be the first power. This only works when things are squared. Because if you take this unit circle again, and we add any pair of these coordinates, x and y, they're never going to equal 1. It only works when they're squared. So that's the only time we can use this, when they're squared. So, what I can do is I can rewrite this as cosine squared over sine squared times sine squared plus sine squared. So I replaced cotangent squared with cosine squared over sine squared. Now, sometimes you have to just use trial and error. Try something. If it works, great. If it doesn't, you end up getting stuck, then try something else. Okay? Because like I said, there's actually two options here. The option I chose, cosine squared over sine squared, or I could have put cosecant squared minus 1 in there. Okay? Either way, I still would end up with the same answer. It just one way might be a little more work than the other one. So, now these two then will cancel. The sine squareds will cancel. And I end up with cosine squared plus sine squared. So this is another thing. You're going to want to put down all the 9 different versions here. Okay? There's 3 different ways of writing this one, there, and these two. Here's 3 different ways to write the second one. In the third one, I only have the 2 ways here. There's another way down here that I could subtract cotangent squared from both sides. You should have them all written down on that sheet of paper where you put that sine or that tangent equals sine over cosine. Okay? That cotangent equals cosine over sine. And the reciprocal ones. So now, what does cosine squared plus sine squared equal? Equals 1. Sine squared plus cosine squared equals 1. So my result here is 1. So by simplifying that expression, I took that and it equals very simple answer of 1.
The closest to 0 you can get.
Okay. Now, other identities. Okay. There are also periodic identities, or what they call periodicity identities, which basically, those are similar to what we've looked at before, just that if I add or subtract 2 pi to any angle, where do I end up? Right back at that same spot in the unit circle. The one thing we didn't focus on at all, we didn't look at tangent. Notice for tangent, it says plus or minus pi. Because if you look at your unit circle, look at the first quadrant and the third quadrant. If you look at the first and the third quadrants, you notice they are exactly the same as far as tangent goes. Positive. Okay. Pi over 6, 7 pi over 6. Square root 3 over 3, square root 3 over 3. 3 pi over 4, 7 pi over 4. They both equal -1. Okay? So when they say periodicity or periodic, that means that that amount, it repeats itself. So in other words, sine and cosine are periodic every 2 pi because you have to go all the way around the circle for them to be the same. So sine and cosine are what we call periodic, and the period is 2 pi because every time I go around the circle, it repeats itself. Where tangent is periodic with pi is its period because every pi units, it repeats itself. Okay? So here they want us to find the exact value of cosine 7 pi over 3. We actually did a problem just like this the other day. Okay? All we need to do is get it between 0 and 2 pi. Once I get it between 0 and 2 pi, I can find cosine of 7 pi over 3. So what do? Subtract 2 pi. So 7 pi over 3 minus 6 pi over 3 equals pi over 3. So the cosine of 7 pi over 3 is the same as the cosine of pi over 3, which is 1/2. Okay, how many more were there? Was there 1 or 2 more examples? 2? Okay. All right. Negative angle identities. Okay. You want to write these down. You're going to add these to the list. Okay. Sine of negative t equals negative sine of t. Cosine of negative t equals cosine of t. Tangent of negative t equals the negative tangent of t. And I'll show you what that means here in just a second then, and how that's related. I actually think I have. Right? It's right here if you're looking. Oops. Back forward. Go. Go. There you go. Okay, they're right here. Okay. Now, notice, if we go clockwise, the angles are negative, right? Okay, we go clockwise, the angles are negative. So if I start going around clockwise, 11 pi over 6 would be the same as negative pi over 6, because I went down negative pi over 6. Or it would be negative 30. Okay? If I went down to 90, or down here to 270 or 3 pi over 2, that would be the same as negative 90 or negative pi over 2. It's just I'm going clockwise instead of counterclockwise. Okay? So if I look at pi over 6 and negative pi over 6, cosine, they're the same. Square root 3 over 2, both of them. Sine, at pi over 6, it's 1/2. At negative pi over 6, it's negative 1/2. Okay? The sign changes. Tangent, positive square root of 3 over 3, negative square root of 3 over 3. Let's pick a different angle. 3 pi over 4. Okay, I've got that one circled. 3 pi over 4, cosine is negative square root of 2 over 2. So if I went to negative 3 pi over 4, that means I have to go over past the negative pi over 2, and that would be the same as 5 pi over 4, right? Okay, negative 3 pi over 4 would be the same as positive 5 pi over 4. They terminate in the same spot. Notice, cosine, negative square root of 2 over 2. Cosine down here at 5 pi over 4, negative square root of 2 over 2. Okay, they're the same. Sine, positive square root of 2 over 2, negative square root of 2 over 2. The sign changes. Okay. All right. Tangent, negative up here at 3 pi over 2, or 3 pi over 4, positive at 5 pi over 4. Okay. So these negative angles The sine of a negative angle is the negative sine of that positive angle. Cosine of a negative angle is just equal to the cosine of that positive angle. Tangent of a negative angle is equal to the negative tangent of that positive angle. So, here they want us to find the exact value of these things. So according to that, the sine of negative pi over 3 is equal to the negative sine of pi over 3. So if it says sine of a negative angle, then I just take the opposite of sine of that positive angle. Sine of pi over 3 is square root of 3 over 2, so it would be negative square root of 3 over 2. Cosine of a negative angle is just equal to positive cosine of that positive angle, which is 1/2. But you could also look at my unit circle. Where's negative pi over 3 on the unit circle? On the unit circle, negative pi over 3 would be, well, let's see. It's pi over 3 is the same as 60 degrees, so if I started at 0 went to positive 60, or I started at 0 went to negative 60, would be the same as 300, same as 5 pi over 3. Cosine is 1/2. Sine is negative square root of 3 over 2. So you could do it either way to get there. Okay. And then we have these identities here involving pi minus t. And these we won't use very often. And more often than not, you're just going to use whatever the angle they give you. So in other words, they ask you to find the sine of 5 pi over 6. That's on your unit circle. Use your unit circle. Okay. Cosine of 2 pi over 3. That's on the unit circle. Just use it to find the answer of negative 1/2. Okay. Anytime they want you to find a value that's on the unit circle, use it. Don't worry about if they ask for a reference angle, don't worry about a reference angle. Just find it on the unit circle. Same with these two. Okay, all right. Okay, does that clear things up a little bit then? Maybe. I know that these are difficult. Okay, they get difficult. People have a hard time with the Pythagorean identities. The biggest thing is that what do I put where? Now you're just looking at very basics of it. In chapter 8, we're going to get really deep into it because we're going to spend the whole chapter, which is actually for us only about a week's worth of stuff, but we will be doing this extensively. Okay, so this is just a little touch of it. But the thing is that look at your identities that you have, and wherever you write them down, you're going to use them on the test. Okay? And try something. If it simplifies, then great. If it doesn't, then try something different to where you can replace it. And like I said, this cotangent squared I had here, I could either replace it with cosine squared over sine squared, or I could have replaced it with cosecant squared minus 1. Either way, I still could have done it. It's just one way is a little bit quicker than the other way. Okay? And sometimes none of the ways are quicker. They just take a while to simplify anyways. Right? And you can't start it here and end up down here and say a miracle happened, because it didn't. Okay? I used to have calculus students a long time ago. They would start a proof of something, and then down at the bottom they would say that it's equal, and somewhere in between there was a miracle that happened. Okay? And usually it's not. No. All right? So that should help you with these a little bit more. Okay? And then that handout I gave you, that's what you need to do for your assignment for the weekend. That's due on Monday. And I am going to actually collect it from you.